Okay, let's start working on some more problems on the semester test review. I messed up the first take on the video for solving 14 and 15, so I'm redoing it, so ignore what's written on the paper there. I'm going to rewrite it on this paper here. We've got the area of a lake the area covered by a lake is 11 square kilometers, decreasing exponentially at a rate of 2% each year, and it's modeled by this function, a of t equals 11 times 0.98 raised to the t. Our first question, A, for number 14, is by what factor does the area decrease in 10 years? The factor that the area decreases by is what we multiply the initial amount by over that time period. So if we wanted to find A of 10, that would give us our new area, and that would be 0.98 raised to the 10th power times 11. So this is the factor that we would multiply by, or that would decrease by in 10 years. So we'll do 0.98 raised to the 10th, and that's going to be 0.817. So either one of those answers would suffice. Part B says what factor does it decrease by each month? So if this is our factor where t is years, and there's 12 months in a year, we know that A of t in months is going to be 11 times 0.98 divided by, over raised to t divided by how many months there are in a year. So this time t is in months. And so if we want to know each month, we're going to plug in 1 month there and find A of 1. That's going to be 11, 0.98 raised to the 1/12, where this is going to be our factor, or this shouldn't say equal because that's equal to 11. It's not equal to that. This is our factor that decreases by per 10 years. And this is our factor that it decreases by over 1 month. So we're going to do 0.98 raised to the 1 divided by 12, and that's going to be 0.998. That would be our answer for part B on number 14. On number 15, we have another function. Again, I started this one and I messed up the video, so I'm going to ignore what's written on that paper. The number of employees in the company growing exponentially by 10% each year. By what factor does the number of employees change? Well, we need to recall from our last 4A unit that the model here is going to be the employees where t is in years is going to start with the initial amount. I'm just going to call that big capital I. However many employees, let's just call it E, big capital E. How many employees we started with times, this is going to be 1 plus our growth rate of 2% or 10%, which is 1 plus 0.1 raised to the t, where t is in years. And that's equal to just our number of employees times 1.10 raised to the t. That's our function. If we want to know how much is t in years, we want to know each month, then we will A of t equals the number of employees times 1.10 raised to the t over 12. And that, because of our rules of exponents, can be written as 1.10 raised to the 1/12 raised to the t, where t is in months. And so this is our factor that the number of employees changes. So 1.10 raised to the 1/12, which is going to be equal to, in our calculator, 1.008. So either one of those would be the correct answer for part A on 15. Part B says every 3 months. So in this case, we take our initial function for years, A of t, and there are 4 3-month periods in 1 year, so this time we would do 1.10 raised to the t over 4. How many 3-month periods are there in a year? So that's going to equal, by our rules of exponents, 1.10 to the 1/4 raised to the t, where t is in 3-month periods. And this is our factor, 1.10 raised to the 1/4, and that will equal 1.024. Either one of those will suffice for your answer on Part B. I'm going to stop the video now for number 14 and 15.